So in front of you, you technically have this. And I made this blue. And then I went like this and made this blue. So you knew that it correlated. Okay. So what we need to spot about this graph is this is going to be the sine graph, the blue sine graph. Now, how can we type it into our calculator? We're going to practice that too. So we're all going to grab our calculators. I'm going to bring up the calculator. Oh, I already did it. So you type in sine x, and then you're going to go, the graphs in front of you, if you look at the x-axis on the graphs in front of you that I gave you, what's the x-axis in? Radians. So I have to go mode, radians. I picked the right mode. And then I can go zoom, trig. We use zoom 6 all the time, which is my standard window, negative 10, 10, 10, 10. If I go zoom trig, the key thing of doing zoom trig is it doesn't always work, but at least it gets you a starting point sometimes. Like sometimes you can't get graph to graph, so it's like your last ditch effort, you press zoom trig. The key thing is you have to pick your mode first before you press zoom trig. Because, watch this, if I go mode, and I go degree, and I go graph, why does it not work? What's this window in? It's in radians, and what did I just change the calculator to? Degrees. So this is actually from, let's look, it's from 8 degrees to negative 8 degrees to negative to 8.6 degrees. Is that what I actually want? No. But after I press degree, I could go zoom, trig, and now it shows up because my window's in a degree window. So when you press zoom trig, make sure you're in the mode you want to be in, which I want to be in radians. Okay? That's like, if I'm stuck, I can at least press zoom trig and have a fighting chance to get to what it would look like. Okay? If I want it to look like what you have in front of your face, and you want to say, I think they match, because they do some bumps, and yeah, I think they match. The best thing that you want to do, what did I tell you whenever you want to check if yours matches something? Make your window match what? The window of the graph, right? If you're checking to see if yours matches, you make your window be the exact same window as this, and it should look exactly the same. It should cut off in the same spot, everything, right? So when you're comparing graphs, which in this case I didn't come up with an equation, so I know that they'll match. But if you are actually coming up with an equation of a graph of a polynomial, or if you're coming up with an equation of a trig function, and you are given a graph and you have to come up with the equation of that graph, you can always type it in and check it, right? Well, just make sure that your window matches the window of the graph they gave you. So in this case, I would go from negative pi to 3 pi with a scale of pi over 2. I'm just going to show you how to do it. So I'm going to go from negative pi, so go to my window, and I go negative pi, it's going to turn to a decimal, 3.14159, keeps going, it's fine, to 3 pi, because that was my x max. And what did it go up by? Pi over 2, right? Each takes pi over 2. I go pi divided by 2, which is actually what it was. And then my y max is 2, and my y min is negative 2. And it went up by 1s. So that's good. And now I press graph. And now does it actually look like the blue graph down there?
Yes.
It actually looks like it, doesn't it? It starts kind of here, it starts kind of there, and then it goes here. Now this one isn't perfect because I started at negative pi, so I actually have to compare it to the negative pi start, right? Not to the start that it actually had. And then I stopped at 3 pi, so it's not going to go below because I stopped at 3 pi, right? Does that make sense? How the heck do we get this graph? Want to watch something? Okay. So if I go, watch me. If I have any x value, I can find its corresponding y, can't I? Using my calculator. If I have an equation and have an x value, my calculator will find its y every single time. How do I do that? So if I go second trace value, you don't have to do this, I'm just showing you. And I want to know what the y is at 0, I hit enter. Oh, it's at 0, 0. And if I go second trace value, I want to do pi over 6. Oh, it's at 0.5. Where are we seeing those numbers at? Where are other places we see them? Second trace value, pi divided by 2. Oh, it's at 1. Where am I getting those values from? Yeah. Your unit circle. What is sign answers? Sign answers are always the what on the unit circle? The y. Can you take out your unit circle? It should be like right next door to you. It should be like your best friend. It should be basically like there at all times. And I have to search for it. Okay. So when I go to draw the sine graph, I'm looking at the sine values, correct? So I'm looking at the radian measures are my x's, and my y's are actually the y, because that's sine theta, right? So sine of 0 is, what's my y at 0? 0. What's my y at pi over 2? 1. What's my y at pi over 3? 0.8660, right? What's my y at pi over 4, which would be halfway in the middle? 0.707. What's my y at pi over 3? A half. So that's where I'm getting this graph from. It's just literally the unit circle spinning. I'll show you. I can't show this. So if I go, all of you have sine graph in your calculator, right? So what I said is, if I want to get the cos graph to be the sine graph, because if I go cos, let's go cos x here, just for fun. It's that graph, right? If I take the cos graph and I move it pi over 2 to the right, it should be the sine graph. That's what I said, right? So let's see. If I take the cos graph and I move it pi over 2 to the right, so I'm going to subtract pi divided by 2 because I want to move it to the right. It draws right over top of the sine graph, doesn't it? And if I take the sine graph and I move it pi over 2 to the right, or sorry, to the left, it's going to draw right on top of my cos graph, isn't it? So they're actually the same graph, only difference is they have a horizontal phase shift. That's it. They're 90 degrees away from being each other. So they have a maximum at 1, a minimum at -1. How often do they repeat themselves? How often do I get a new graph? Every 2 pi or? Every 360 degrees. Because it's drawing the unit circle, isn't it? And then it's repeating the unit circle again. And then it's repeating the unit circle again. And then it's repeating the unit circle again. So your sine and cos graphs are literally, they're called the period of the graph. It's how long it takes to repeat itself. It repeats itself every 2 pi or 360 unless it changes. So we're going to go to our notes here. 5.1 graphing sine cos functions. We're going to skip this part because I was trying to speed us over without physically drawing it ourselves. But what we could do if we wanted to draw it ourselves is we could put in like 0 and then put sine 0 in our calculator, get the y. Put in 45, sine 45, get the y, right? Or we could go right off our unit circle. What I need for us to highlight here are some of our important information items. So the period, and it's just because it bumps down, is the length of the interval of the domain over which a graph repeats itself. That's the period of the graph. It's the horizontal amount that it repeats itself. And if you look on the x-axis of those graphs I gave you, the x-axis is in radians, right? It could be in degrees as well. So the period of a sine and cos graph that has like the parent function is 2 pi or 360 degrees. What would change that? What would make it be able to shrink? What type of transformation could we apply to it that would cause it to shrink or lengthen? Yeah? Which stretch? Horizontal or vertical? Yeah. If we horizontally stretched it by a half, my period would go from 360 to 180, right? If I horizontally stretched it by a factor of 2, it would go from 360 to 720. Right? The horizontal stretch is the only thing that can affect my period of my graph because it'll stretch it wider or narrower, and it's only the horizontal that's going to affect that. Right? Okay, that's one thing. So that's the period. Then we have the amplitude. The amplitude is half the difference between the maximum and minimum values of periodic function. Off of a graph, we can do the amplitude as the max minus min divided by 2. That's how we'd find the amplitude off a graph. And we will come back to that later. So the amplitude's half the distance, yeah. So on a normal sine graph, if we go to the one we had before, this one, what would my amplitude be? How far is it from my minimum to my maximum? It's 2. So my amplitude would be 1, because it's half the distance. Right? And I could use the formula if it was off of a graph, because the amplitude equals the absolute value of the max minus the min, and the min is -1 divided by 2, which is the absolute value of 2 divided by 2. Absolute value just turns into every negative positive, right? So it would be 1. So I could use the formula, or I could literally count, hey, it's 1 to 1, that's a distance of 2, the amplitude is 1, because it's half that distance. Okay, so you can use the formula, or you can count it if it's a graph. So, I need to go here. The other thing to note about the amplitude is always positive. Very important. If they ever ask you an amplitude question as multiple choice and something was negative, you just cross it off. Because your amplitude is the distance, half the distance from the min to the max, and distance can't be negative. So your amplitude. So, what's the amplitude of a sine graph? What did we say it was? It was 1. What's the domain of a sine graph? Does it ever stop? No, it's periodic function. It would just keep repeating itself over and over and over. So the domain is x such that x is an element of the reals. Or in interval notation, negative infinity to positive infinity. What's my y-intercept of my sine function? Yeah. That's my range. What's my y-intercept? Yeah. My y-intercept at 0, 0, and then my range is going to be -1 is less than or equal to y is less than or equal to 1, y-er. And the reason why those symbols are actually in the same direction, they both look like less than signs, is because you're reading from the variable. So if I read this direction, it's open to y, so y is greater than or equal to -1, and if I read from this direction, y is less than or equal to 1. So they always make slanted L's when you sandwich them, and you go from low to high, because you're reading from the variable. And in interval notation, it's way easier. You just go -1 to 1 square brackets because it's equal to them. What's the period of a sine graph? 2 pi or 360 degrees. And what are my x-intercepts or my theta-intercepts? Where are they crossing at? This blue graph. Pi, 2 pi, 3 pi, every what? Every 180, every pi. So we can write it out like, why do I keep doing this? Just go back. So we can write it out like this. We can go theta equals pi, 2 pi, 3 pi, etc. Or we can write it as a general solution. Oh, it starts at 0 as well, right? 0 is one of them. The general solution is like the general solution we did before with coterminals. So you can go 0 is my first angle, and I add pi to it, right? And I keep adding pi, keep adding pi, keep adding pi, keep adding pi, correct? Or I could take off pi, take off pi, take off pi, take off pi, and I get it. So I'm going to go 0 plus pi n, and then what do I have to follow behind with? N, E, anyone remember? I, for integers. Because it's all the negatives and all the positives. Do I need to write a 0? If this first angle I start with a 0, do I have to write 0 plus? No, they're literally just going to write it as pi n n e I.
What does n represent?
N is just what I'm going to fill in. So I can fill an integer in for n and I get every answer. So if I fill the 0 in, I get 0. If I fill the 1 in, I get pi. If I fill the 2 in, I get 2 pi.
Okay.
3 in, I get 3 pi. So you could technically go theta equals pi a, where a is an element of the integers, or theta equals pi c, where c is an element of the integers, and it's just a variable I'm using.
Okay.
And we label it as, everyone labels it as an n, and I don't know why. It's just what we do. Okay, so that's sine. We're going to flip over. What's the amplitude of a cos graph? 1. It doesn't change, right? Apparent cos graph would be 1. What's the domain of a cos graph? X is an element of the reals because it keeps going on for life. What's the only thing that's going to change between a cos and a sine graph? The y-intercept and the x-intercept. That's it. Is my range going to change? Is my graph any higher or lower than a sine one was? No, it's just a horizontal shift, right? So if I have a horizontal shift off of it, then that means my x-intercepts are going to be in different spots and my y-intercept is going to be in different spots. So my y-intercept is 0, 1. The period is still 2 pi or 360 degrees because I'm drawing it right off the unit circle, which repeats itself every 360 degrees or 2 pi. The range is from -1 is less than or equal to y is less than or equal to 1 YER. In interval notation, it will be -1 and 1. So the top one is set notation, the bottom one is interval notation. And then my intercepts, let's look at the graph. The cos graph is the not blue one. So my first one is at pi over 2, then 3 pi over 2, then 5 pi over 2. How often are they happening? Still every pi, right? Every pi, every pi, every pi. But in this case, instead of starting at 0, what am I starting at? My very first positive one. My first positive one for sine was 0. What's my very first positive principal angle for cos? Pi over 2, right? So we're going to go theta equals pi over 2 plus pi n NEI. So the very first one is pi over 2. And then I go pi, 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 pi. So you have a little formula sheet. Remember that I told you to make a little another sheet of your own so that you can memorize formulas on it and put it near your other formula sheet. You want to grab that out? We're going to put a little info on it.
Can you quickly explain period again?
Period's how long it takes to repeat itself horizontally. So if we look at this graph here, if I look at the sine graph, I'm going to use brighter color. I'm going to make it be pink. If I start here and go past a max, past a min, back to this value, what's going to happen after 2 pi? It's going to repeat. So the period's how long horizontally it takes to repeat itself. So from 0 to 2 pi is the distance of 2 pi.
Okay.
or 360 degrees, which is the same in degrees. Does that make sense?
Yeah.
Okay. So on your little formula sheet, I'm just going to write up here. On your formula sheet, I'm going to go if I have trig graphs. If I have a trig graph and I need the amplitude, I can use the formula, I should have equal sign. I can use the formula absolute maximum minus minimum. The absolute value of the maximum minus minimum divided by 2. That's one formula I can use, right? Or I could just calculate half the distance from the min to the max. Or I could calculate half the vertical distance from min to max. So that's off of a graph, how I could find the amplitude. So if I count from min to max and it takes me 6 to get there, then my amplitude would be 3, because it's half of it, right, from minimum to maximum. Off of a graph, the period is how long it takes horizontally to repeat itself. Now what you can do is you can actually figure from a max to a max. I'll show this in a second. You could go from a min to a min. You could go from a max to a min, but you'd have to times it by 2. And I'll explain these. And then there's another way, or you could literally just count it, so I'll show you that in a second. Let's get it written. So max to max, a min to a min, max to a min. If from a max to a max is a full period, then a max to a min would be half of it, right? So I'd have to find the distance from max to min, and then I'd have to take that answer and times it by 2 to get the period. So we're going to go back to the graphs that just so I can show you. Or look there. We'll come back to this in a second. If I go here, for this purple one that I did the period of, I actually started at the y-axis. I went past the max, past the min, and then I went back to that same height on the y-axis. So that's one way you can do it, which is what I did. That's the first way I showed you. I started at one place, went past the max, past the min, back to that same height. How long did it take me horizontally? But what I could have done, nope, that's not working, is I could have went from a maximum to a maximum on the same graph, right? And figured out the distance it took me to get from here to here. How would I do that? Yeah, so I could final minus initial. So I go 5 pi over 2 minus pi over 2, and I get 4 pi over 2, which is 2 pi. Same thing, right? Give me the same answer. Or I could go from minimum to minimum. If I went from this min to this min, I would actually not be able to go final minus initial because this one's negative. So I could go final initial as long as I went minus a minus, right? Or I can say, hey, I have pi over 2 to get me here, and then I have 3 pi over 2 to get me here, and I add them, and that's 4 pi over 2, which is 2 pi. Same thing, right? Now, some people would say, why would I ever go from a min to a max if I could go from a max to a max or a min to a min? Because sometimes they don't land nicely on spots. Also, sometimes you're only given a min to a max. You're given such a small portion of a graph. So if that happened, I could go from a min, or a maximum, to a minimum. So I would go 3 pi over 2 minus pi over 2. which gets me 2 pi over 2, which gets me pi. But what do I need to remember that when I go from a max to a min or a min to a max? Yeah. You got times by 2 because I only gave you half a period, right? From min to max. I take my answer, I times by 2, and I get 2 pi. You see how I found the same period doing it whatever way I wanted to? Which way is best? The one that has actual numbers. So sometimes a max to a max isn't nicely accurate at a certain spot horizontally, so those are not good choices, right? Sometimes starting on the y-axis, going past the max, past the min, back to that same height is the best one. It all depends on what the graph looks like, and we're going to deal with that. Not today, though. Okay, so on that same sheet, we're going to go over what if I give you an equation. So this was a trig graph, right? We could pull that stuff off. What if I give you a trig equation? So the trig equation could be y equals a sine, transformations is coming back with a vengeance, bx minus c plus d, or y equals a cos bx minus c plus d. You don't need to memorize these because they're at the very bottom here on your formula sheet. It gives you the transformed form of a trig, which is exactly these two formulas. From these formulas, amplitude off of a graph, we had to do max minus min divided by 2, the absolute value, or we had to count from minimum to maximum and divided it by 2, correct? That's off of a graph. Off an equation, amplitude equals the absolute value of a, which is just a in this case. So if my a was negative 7, my amplitude would be 7. If my a was negative 53, my amplitude would be 53. That's all it is. There's no actual math needed here. You need to just memorize that. How do you get the amplitude off an equation? It's the absolute value of the a variable. Okay? How do I get the period off of an equation? I'm going to give you two formulas, but then we're going to use transformation so we don't screw this up. So the period off of an equation is 2 pi over the absolute value of b, or 360 degrees over the absolute value of b. Those aren't on your formula sheet. Those are for you to memorize, but you don't really need to memorize them if you know your transformations. What's the only thing that we talked about that would make my period go from 2 pi to pi, from a period from pi, or 2 pi to 4 pi? The horizontal stretch factor, right? On this letter, what is, on these equations, what's the horizontal stretch factor letter? B. Why the heck are they dividing by b if the horizontal stretch factor multiplies? Because it's a reciprocal. Exactly. So we can either do the formulas like this, 2 pi over the absolute value of b, or indirectly what that means is 2 pi times the horizontal stretch factor. Why would that be? Because in this case, 2 pi times the horizontal stretch factor, if you're dividing by b, that's like multiplying by 1 over b. Correct? It's the same thing. That just looks awful, so that's why they don't write it that way. Because you're multiplying by the horizontal stretch factor. Do you even need to memorize the formula if you understand what horizontal stretch factor does? No? If you know that the sine graph and the cosine graph repeat themselves every 2 pi, you can look at the horizontal stretch factor as long as you know to flip it and multiply by it, boom, you have the period. You don't need to memorize formulas. If you're like, I hate transformations, memorize formulas. It's totally fine. What's the worst thing that happens though? People will tell me that b equals the period. So I'll give them this. Y equals 3 sine. You're like, that's just stupid. You'll do it. 2x minus 4 plus 7. Let's say it's like that. People will tell me the period is 2. Because the amplitude is 3. That one's easy. Amplitude is the absolute value of a. So say it's negative. Amplitude equals 3. It's the absolute value of amplitude. So let's think about it this way. Amplitude A. Start with same letter. You can use them, right? A, amplitude, boom. Does period start with the letter B? Now, if you tell me the period equals 2, you actually found the period. It's a wonderful thing. I don't even know what it is, but you found it. It's the period. It's Satan's math. They will always put the period as one of your answers. When they ask you for the period and they give you an equation, they'll always leave one of the multiple choice answers be the period. The period is the answer to nothing. The period is the answer that will pull you to it. The period is a distractor. The period is not your friend. Do not pick the period. So if they ask you for the period, don't think the period is the period. That would be like Paula. I had a Paula in my class at the time when I was telling about this. I'm like, it'd be like Paula was Bala, right? Paula is not Bala. So period is not period. Do not tell me the period is the B value, because that's the period. It's a distractor. We don't pick it. You're like, of course I would. You will. Don't do it. Just, strive not to choose it, because it's just so pretty. It's just like right there. You just like wanted. There it is. Okay, don't pick it. Don't do it. The B value is 2. The period of this would be what? 2 pi over 2. Because the period helps us get the period, but it's not the period. So we can either say 2 pi divided by b and get pi, or we could say, hey, it's a horizontal stretch factor by a factor of a half. So I'm going to multiply by a half, which makes 2 pi become pi. Same thing, right? Period is not the period. Don't fall for the period. Okay? So these are your formulas off of there. There's one extra one I want you to write down that we're not using today, but I want it because it's going to be in the same sheet, and I don't want you to have to take the sheet back out again unless you want to. The D value on both of these is called the midline. So it would be at y equals d, and it's the line that cuts the graph in half horizontally. Well, the horizontal line that cuts the graph in half vertically, actually. Line that cuts the graph in half vertically. I'm not really discussing it today, but I just, since you got the paper out, might as well put it there. I'll do a quick little rundown of it on the other graphs, but so if we go back to these graphs, what's my D value on either of these? Sin x and cos x. Trick question, yeah.
Never mind.
You might have been right. Now I said trick question and totally made you not answer. If there's no number at the back, what is it going to be? 0. We have plus zeros at the back of both of these indirectly, don't we? So our midline is at y equals 0. Y equals 0 is what line on my graph? The y-axis is the line y equals 0, right? And the x-axis is actually the line x equals 0. So both of these graphs have a midline here on the x-axis. And how do you know if your midline's right? If you count up from it and you count down from it, you should have the same amount, which should be your amplitude, right? So if I count up from my midline up, that's a distance of 1. If I count from my midline down, that's a distance of 1. So from midline to maximum, midline to minimum is also your amplitude as well. Halfway. Okay? So your midline literally cuts the graph in half vertically. All right. Yeah.
So is your midline always 0?
Nope. If our D value changes, then our midline changes. So if we had like a plus 7 at the back, then our midline would be 7. Yeah.
Can I just go to the bathroom?
Yeah.
Thank you.
Yeah.
Why is it cutting it in half vertically if it's going this way?
Well, it's a horizontal line, but cutting the graph in half vertically, like it's cutting the vertical distance in half.
Oh, okay.
So it's totally a horizontal line. That's why I said it cuts it horizontally. I'm like, no. It's a horizontal line that cuts it vertically, because you could fold it in half right there, and it wouldn't look pretty. Like you'd have them. Well, I guess it would look pretty because there'd just be a whole bunch of mountains, or valleys, options. Leave that to you to choose. So I just want to go here. All we're going to go over today is this. We're going to come back to this box. Don't worry. We're going to fill it in. I just want to go here so you can do a little bit of homework today. I just want you to be able to find the amplitude and the period from an equation for tonight. That's it. Amplitude and period. So how do I get the amplitude from an equation? I don't like green. How do we get the amplitude from an equation? You have a formula sheet in front of your face that tells you how to, yeah? One you wrote down?
Max minus.
It's on a graph, on an equation. It's what? A. It's the absolute value of A. So often in a graph where you do max minus min absolute value divided by 2, off an equation, it's literally just the absolute value of A. So the amplitude for this one, don't write amp on a test. Amp is like wattage. Like you can play music with an amp. There's all these great things. Amp is not amplitude. Amplitude is amplitude. So the amplitude of this one is the absolute value of 3, which is just 3. We agree? What's the amplitude of this one? 2. So really easy question if you remember that that's the amplitude on an equation. Really bad question if you don't, because then you're just like, oh crap. Could you type these into your calculator and use the graph formula, max minus min divided by 2? Sure. Way harder work. I've seen it done on diplomas and unit tests. Totally fine, just to get the same answer if you forget that A is. The amplitude of this number 3? What's the amplitude of number 3? 3. Please don't ever give negative amplitudes. What's the amplitude of 4? It's a fourth. Not a trick question. It's fourth. It's a half. I looked at the horizontal stretch, which is totally not what it is. Boom, boom. A half. Deep breaths. Deep breaths. Okay. Ignore middle. Middle, you can put a big old smiley face in the middle if you really like to. I don't really care about that. We're into the end. The period in degrees and radians. So what's the period of this first one? Well, I know the B, or the period, the B value is 2. The period is not 2. That's a distractor. What's the period? Period equals 2 pi over 2, or pi. Or the period equals 360 degrees over 2, which is 180. How the heck did it get cut in half? How is that possible? How did it go from 360 and 2 pi to 180 and pi? What transformation happened that would do that? Horizontal stretch by a factor of 1/2, because it flipped. So I went and took my 360, I times it by half, boom, 180. Took my 2 pi, times it by a half, boom, pi. But can I use the formulas? Absolutely. Okay, I'm going to change number 4 to -1/4 just to make a point. But you can just do that. This one here is going to be 2 pi over, what's my B? 3. Or 360 degrees divided by 3, which is 120 degrees. We know it's a horizontal stretch factor by a factor of 1/3, so I'm multiplying by 1/3 as well, which will get me the same answer. Number 3, I actually have a horizontal stretch factor by a factor of 2. So instead of 2 pi and 360, I'm going to get 4 pi and 720, or I can use my formulas. Period equals 2 pi divided by B. B is 1/2. When I divide by 1/2, it's like multiplying by 2. So that's why I'm getting 4 pi. So 360 divided by 1/2 is 720. The last one, people will give me a negative period. They're going to tell me that it is 8 pi, -8 pi. Can my period be negative? No, because the formula is actually the absolute value of B. all of these were just positives, right? So not only can my amplitude only be positive, the period can only be positive too, because it's a distance. It's a horizontal distance it takes to repeat. Amplitude's the distance from min to max divided by 2. So both of them are distances, they need to be positive. So the period of this one is going to be 2 pi divided by the absolute value of negative a quarter. Divided by negative a quarter is multiplied by 4, so I get 8 pi. Do you guys know why the absolute value is always positive? Other than someone told you one time a while ago? Does anyone know? Yeah?
Since you're going to make this answer, it does put another way going left and going right, it would still be the same magnitude.
Yeah, so that's why the absolute value, okay, because you're saying, you're actually explaining that, yes, because the distance is the same. So the definition of absolute value is that the distance, that value is from 0. So negative a quarter, the absolute value of a negative quarter, your calculator's going, what's the distance of negative a quarter from 0? And it's going to say a quarter, so that's why it turns it positive. If it said absolute value of negative 7, your calculator is going to say, okay, what's the distance of negative 7 to 0? Oh, it's a distance of 7. So the absolute value is the reason why they always turn positive is the distance away, that value is away from 0. It's distance. That's why it turns positive. Yeah. Yes. So your homework is short on here. Your homework is going to be to finish page 2 of that thing I gave you, the solving, that handout I gave you at the beginning, and then a tiny bit of homework in here. So I want you to finish page 2 of the handout I gave you. Because we're going to go through it. Number 5, you don't have to sketch them. It says to sketch, don't sketch. 4 and 5. So that's very little. So you can work on the other things.